everyone, my name is Dami, and today I'm going to have my first video, and it's going to be on calculus. So the first thing I'm going to be talking about in this video is derivative functions. And as I have on my board here, the derivative is used in solving problems involving tangent lines and velocity functions. And the first concept you're going to be taught in calculus, especially in derivative, is making use of the difference quotient before you're taught other basic principles of derivative. So here I have a question which is asking me to find the equation of a tangent line to the parabola y equal to x squared at the point P11. The first thing to ask yourself is, what is even the tangent line, right? A tangent line simply means if I have a curve, for example, the tangent line is the line touching the curve. So it's just going to be like a straight line touching any point on the curve, right? So if I'm asked to find the tangent line, the first thing that comes to mind is I need to know my slope, right? And that's basically what the derivative is used to find, the slope of the equation. So in finding this, I'm going to make use of my difference quotient, which I have above here. So I have my equation y equal to x squared. So I have y equal to x squared. Now I'm going to have f of x plus h, right, minus f of x, right, divided by h as the limit of h approaches 0. Now the next thing I'm going to do is I'm going to plug my x plus h into the equation I have here, and I'm going to have x plus h all squared minus x squared divided by h as the limit of h approaches 0. The next thing I do here is to expand my brackets, and when I do so, I'm going to have x squared plus 2xh plus h squared negative x squared all over h, right? Something here is very unique. The x squares cancel out. So now what I'm left with here is 2xh plus h squared all divided by h, the limit as h approaches 0. The next thing I can do here is to factor out my h, and when I do so, I'm going to be left with 2x plus h divided by h, and that cancels out, right? So I am left with the limit as 2x plus h, right? If I plug in 0 into my equation, I'm going to have 2x plus 0, which gives me 2x. Hence, the slope of this equation is m equal to 2x. So in order to find the equation of the tangent line, I'm going to make use of the point slope formula, which tells me that y minus y1 equal to mx minus x1, right? So here I have my points. My 1 is x, my y is 1. So I have y minus 1 equal to 2. And how did I get 2? I'm going to plug in 1 for x, and I have 2. And I have x minus 1. So basically I'm going to simplify my equation. So I have y minus 1 equal to 2x minus 2. And y equals to 2x minus 2 plus 1. Hence y equals to 2x minus 1. And this is the equation to the tangent line. So moving on, I have velocity problems. The derivative is also used to find velocity problems, especially the first derivative. So if you're given a position function or a distance formula function and you're asked to find the velocity, the first thing that should come to mind is I have to find the first derivative, right? And in this situation, we are asked to find the velocity after t equal to 2. And we have our height function, which is y equal to 40t minus t squared. So I have y equal to 40t minus 16t squared, right? Now I'm going to make use of my difference quotient to find the derivative of this formula. So I have, I'm turning off the question. So I'm going to have, okay, so I'm going to have 40 x plus h minus 16 x plus h all squared, right? Minus, yeah, the space is a little bit too small. I think I'm going to move over here. So I have 40x plus h minus 16x plus h all squared. This here represents what I have here, minus f of a, which is the original function I was given, but I'm going to plug in x instead of t. So I have 40x minus 16x squared as the limit of h approaches 0. That's what I'm going to have. So now I'm going to have to expand my bracket, and this is going to give me 40x plus 40h, and I have negative 16x squared plus 2xh plus h squared, and here I have negative 40x plus 16x squared all over h, right? So I'm going to have 40x plus 40h, negative 16x squared, negative 32xh, negative 16h squared, negative 40x plus 16x squared divided by h. The next thing I'm going to do here is to cancel out my like terms. So 40x cancels out, 16x cancels out this, and that seems to be it. So I have 40h, negative 32xh, negative 16h squared, all divided by h as the limit of h approaches 0. Now, I can factor out my h, and when I do so, I'm going to have 40 minus 32x minus 16h, all divided by h as the limit of h approaches 0, right? So this cancels out, so I have 40 minus 32x minus 16h, plug in my 0 for h, so I have 40 minus 32x. So this is my velocity function. That's it.